Hello, grade 9s. Today we are going to talk about converting decimals into fractions. Last lesson we talked about fractions into decimals and we learned a bunch of different strategies. Just to quickly recap what we talked about having those 6 common sight fractions ready to go in our brains, locked and loaded every single time. Similarly, those sight fractions we should be able to see and notice in decimal form and then convert back. That can be one of the strategies. So acknowledging a sight decimal, which is equivalent to one of our sight fractions, and working backwards. The other thing that we learned about converting fractions into decimals is when fractions have value in terms of a denominator that is a multiple of 10. Sorry, not a multiple of 10, a power of 10. When they have a power of 10, we would be able to use place value to convert backwards. Now, fun little fact, every single decimal that terminates, which means it does not repeat, it does not go on forever, can be converted back into a fraction using powers of 10. So this kind of same strategy, working backwards. We'll chit-chat about it, see what it looks like moving forward. But there's one final strategy that two final strategies that we talked about. Strategy number 1 is that fractions that have denominators of 9 will end up giving us repeating decimals. Which means if we're backtracking, if we're doing this in reverse, any decimal that repeats can be written as a fraction with 9s as the denominator. Okay, now this lesson should be a little bit easier than the last one because we're simply working backwards. We have all the strategies, we have all the skills. Now we're just doing everything in reverse. So, here we go. To convert decimals to fractions, we're going to use the same methods that we talked about the other direction, but now in reverse. Now, big important tip to kind of identify first is that every time we have a decimal that is greater than 1, so like 1.5 or 31.125 or even if, and when we talk about greater than 1, we're talking about magnitude, not direction. So I could be talking about negative 6.3 repeating. What we're going to do first, always in those instances, is we are going to convert to a mixed fraction first and then into an improper fraction. It's hard to go straight from a decimal value that has a whole number or an integer that is not 0 in the left-hand side of the decimal, and then it is to go straight into improper fractions. So we're going to go mixed first, then improper. Last but not least, we want to make sure all of our fractions are in simplest form. If we go ahead and we do some conversions, we might not take or notice the fastest route first time round. And if that's the case, we need to make sure that whatever we end up as our fraction is simplified. And we're going to see what that looks like in this first example. Now, in this first example, you look at 0.2, and hopefully it triggers in your brain, and you're like, oh my gosh, that's a sight fraction. I know that 0.2 is equivalent to 1/5. And if you know that, fantastic. Now, there's more than one way to get to that answer. You do not have to show both, but I want to talk about both. This decimal here is terminating, which means it does not repeat or it does not go on forever. Okay? Which means we could use place value to turn this decimal into a fraction. Now, place value, I look at the last digit in that fraction and identify what place it is in. That is in the tenths place. So in other words, I can say that's 2/10. And 2/10 is 2/10 as a fraction. Now notice how this fraction 2/10 can be simplified. And I can simplify it by dividing both the numerator and denominator by 2. And I end up with 1/5. Now you'll notice these two answers are identical. And they should be. Regardless of what strategy you used, you will and should get an identical answer. However, one method was faster than the others. So if we can look and recognize those sight fractions, we should be able to get there in a quicker process than if we go ahead and use place value in this case. The second one, again, we can talk about in two different ways, but the most important thing to acknowledge about the second one is the second one has a value greater than 0. There's a whole number component to that decimal. So our first step is to convert that into a mixed fraction. Now, this component, the whole number component, the part before the decimal, is just going to be the whole number part of my mixed fraction. And then I look at 0.6 repeating. Now, 0.6 repeating is not technically a sight fraction, but can easily be found using sight fractions. So some of you might be like, I know that 0.6 repeating is the same as 2/3. So I can write that as 1 2/3. Now in grade 9, we want all of our fraction answers to be improper fractions unless we're talking about a word problem. And the reason we want improper fractions is because the math is actually easier to do when it's in improper form, and because we're developing the skill, or like the first couple of steps of the skill of dealing with fractions mathematically in different operations. We want to leave our answer in that form that would help continue doing additional operations to when we get to that point. So in grade 10 or 11 or 12, we will get to a point where we're doing more than just our basic operations with fractions. So we want to make sure that we're kind of prepared and we're used to getting it ready to continue doing computations with that. With that being said, I want to convert this into an improper fraction. And doing that, I have 5/3. Now that's my final answer. But again, maybe your brain didn't see that sight fraction at first. Maybe your brain's like, okay, I acknowledge that it's 1 and something because I have the 1.6 repeating. So we have 1 and some fraction. Now 6 repeating, you might be like, repeating decimals will end up having denominators of 9. And there's only one digit that's repeating, it's a 6, which means there's only 1 9 in the denominator. And that one digit, that 6 that's repeating, makes it my numerator. Now, if I take a look at this before I convert to improper form, 6/9 can be reduced. I get 1 2/3. And if I am showing that work, I do need to show the division on the top and the bottom. It is not acceptable to do this. Just divide by 3. And it doesn't matter that placement. It's also not acceptable to put that divide by 3. Things are going away. Just in the middle. Because that is very different than dividing by 3/3. Dividing by 3 at the top and 3 at the bottom. Because 3/3 is the same as 1. And divided by 1 doesn't change my final answer. So if I show that work, I have to show it at the top and the bottom. Okay, next step is I simply go ahead and convert to improper, and we've already done this on the other side. So I can see that I get matching answers. Again, I will not ask you to use one method or the other. I want you to be able to go ahead and do what works for you. Okay, so that first strategy was acknowledging our sight fractions. The second strategy is talking about place values. And it says that any decimal that terminates, which means it stops, it does not go on, it can be placed as a fraction by using the place value to determine the denominator. And we're going to jump right into these examples. Now, the first one, I read that as 34 hundredths because the last place value of the decimal is in the hundredths position. So I'm going to turn that into 34/100. And again, as I do this, I need to make sure my final answers are reduced as possible. So I do want to make sure that my final answers have been simplified. In this case, the top and bottom are both divisible by 2, so I end up with 17/50. The next example, I have negative 0.223, or I can read that as negative 223 thousandths. So when I take a look at that, if I have a negative decimal, I'm going to have a negative fraction. The last place value is in the thousandths position. So that means I have my non-zero values, my 223, over 1,000. Now, if I could reduce this, I would, but this question is not actually reducible. This fraction cannot be simplified. And I could use my divisibility rules to figure out why it's not simplified. It can't be simplified. And I know it's not even, so it can't be divisible by 2. If it's not divisible by 2, it's actually not divisible by any even number. So if something's not divisible by 2, it's also not divisible by 4, 6, 8, 10, 12, 14, etc. I could skip all of the even numbers because it is not divisible by an even number if it is not divisible by 2. I also know this fraction is not divisible by 3. First of all, I know that 1,000 is not divisible by 3. And I know that because the sum of the digits is not a multiple of 3. 1 plus 0 plus 0 plus 0 gives me 1. And 1 is not divisible by 3. So I don't even have to bother looking at the numerator, although the numerator happens to not be divisible by 3 either. It's not divisible by 5 because it doesn't end in a 5 or a 0, that numerator. It's not divisible by 10, etc. And I could go through a bunch of different divisibility rules, but this one cannot be reduced. So this is how we use place value. Next, repeating decimals. Repeating decimals can be written with a denominator made up entirely of 9s. And again, we're working backwards with the strategy, so that means the number of digits that repeat will be the number of 9s in my denominator. The numerator will tell me what that decimal value is. So here I have negative 0.5 repeating. Remember that negative doesn't impact my final answer other than the fact that if it was a negative decimal, it's going to be a negative fraction. And a communication error thing to point out is that that negative either has to be written in front of the fraction or in front of the numerator. It cannot be written in front of the denominator. Okay, I have one digit that's repeating. It's just the 5, which means I only have 1 9 in that denominator. The digit that's repeating is 5, which means the numerator is 5. This cannot be further simplified, so this here is my final answer. Next one here. I have 3 digits that repeat, which means I will have 3 9s in that denominator. The digits that repeat are 3, 4, 5, which means my numerator has to have 3 digits, and those digits are 3, 4, 5. I'm going to take a look to see if it's divisible by anything. And we're going to use our divisibility rules to help figure that out. Now, if I'm looking at denominators of 9, hopefully in my head I'm like, okay, I know that denominator is divisible by 9s. It's divisible by 3. And that's probably the first place I'm going to look because it's not divisible by 2. That denominator is not even, which means it's also not divisible by 4, 6, 8, 10, etc. It's not divisible by 5. So I'm going to look at the numerator. That numerator, if I add up the digits, 3 plus 4 plus 5 gives me 12, which means my final answer will be divisible by 3. So I'm going to divide the top and bottom by 3. Now, when I think about this, I kind of look at 345, and in my head, mental math-wise, I can do that division. The way that I do division is I notice that 45 is divisible by 3 and 300 is divisible by 3. And so I'm kind of doing those separately and recombining that. 300 divided by 3 is 100 and 45 divisible by 3 is 15. So when I go 345 divided by 3, I get 115 as that final answer. Again, I'm welcome to do short division on the side. I can do whatever I need to feel successful. 999 divided by 3 will be 333. Again, welcome to use mental math, or welcome to do short or long division on the side. Now I'm going to keep on going. Notice if anything is further reducible. But when I add up 1 plus 1 plus 5, the digits of the numerator, it is giving me an answer of 7. Which means it's not divisible by 3 and it's not divisible by 9. And the denominator, although divisible by those things, cannot be reduced as an entire fraction because they don't have a common factor to the numerator other than 1. Man, that was a big ramble of things. Just off the side here, I want to show an example of if I had a repeating decimal that had a whole number component. So like 27.46 repeating. Okay. If I was converting this to fractions, my first job would be converting it to a mixed fraction. That 27 is the whole number component, the 27 is the whole number component. That 0.46, there's 2 digits that repeat, which means I'm going over 99, 2 nines. Those 2 digits are 4 and 6. And then I can go ahead and reduce if it is possible. In this case, I don't immediately see anything that 46 and 99 have in common. Knowing those divisibility rules on the top of my head really quickly helps me identify that. And then I can convert this into an improper fraction. Now you might be like, Miss T, why did you choose such ridiculous numbers? And quite honestly, I didn't think it through. But we can do it. So 99 times 27, in my head, how I multiply by 99s is I kind of do partial products. So instead of doing 27 times 99, I do 27 times 100 minus 1. Because I can multiply by 100 really easily. I can multiply by 1 really easily. So instead, this is how I do it in my brain. So I go 27 times 100, and then I do 27 times 1, and when I perform that subtraction, I get 2,673. 2,673 over 99. And again, the strategy still works, even if I have a digit other than 0 prior to the decimal. Okay, on this last page, there are 8 examples. I would like you to pause the video. I would like you to try these examples. Try them on your own. Once you've tried them on your own, turn to a person sitting next to you and see if you can talk through what you did in your head to that person. Now, your process might be different than the person next to you's process. It doesn't mean that process is wrong, but we want to get used to and comfortable practicing those different strategies and helping notice as much as we can about those decimals. Once you are done all that, unpause the video and I'll kind of go through those 8 examples with you. Okay, hopefully you've done that. Hopefully you paused, you chatted, you figured it out, and then now we're back. I'm going to go through these relatively quickly because I have now assumed you have gone through them with a partner and you've tried things for yourself. So, question number 1, 1.25. My first step is converting that into a mixed fraction. So the 1 over here becomes the 1 in my mixed fraction. That 0.25, that's a sight fraction. 0.25 is the same as 1/4. And of course I wanted to convert my final answer to be improper, so I end up with 5/4. Please know that when I write fractions, writing them on top of each other and writing them kind of sideways like this mean the exact same thing. B, I have a repeating decimal, and I'm going to have a fraction with a denominator of 9s. There's only 1 digit repeating, which means I only have 1 9 in the denominator. The digit repeating is a 4, and my final answer could not be reduced. So this is what I've got, -4 over 9. The next one, again, I have a negative decimal, so I'm going to have a negative fraction. When I look at 0.125, I'm immediately thinking, hey, that's my sight fraction. My sight fraction is 1/8. And here we go. Now, if you do not recognize the sight fraction, in theory, you can also say -125 over 1,000. If you do that, we do still need to simplify the top and bottom. You don't have to do it in one big step. Do it as many steps as you need. So I'm going to divide the top and bottom by 25 as my first step. I get -5 over, okay, mental math. If I'm thinking how many 25s are in 1,000, I know that there's 10 100s in 1,000, and there's 4 25s in 100. So my mental math process is, as I'm saying, I have 4 for every 100, and I have 10 hundreds. 4 times 10 is 40. And that's great and all, but it's not fully simplified. So I'm further simplifying, reducing the top and bottom by dividing it each by 5. And I get negative 1/8. Again, same answer, longer process. D. When I take a look at D, 0.36 does not immediately ring any bells. It is not repeating, which means I'm using place value. This number is read as 36 hundredths because the last digit in the decimal is in the hundredths position. So I'm going ahead and putting 36 over 100. Again, always looking to see if I can simplify. Yes, I can. I notice that both of these numbers are divisible by 4. If you didn't notice that right away, you could divide them both by 2. Whatever you notice right away is fantastic. And when I divide the top and bottom by 4, I get 9 over 25. Okay, next one, 0.006, or I could read this as 6 thousandths, because that number there does not look like a sight fraction to me, but it terminates, which means I could use place value to help figure things out. That 6 goes over the place value of 1,000. And again, I simplify where I can. I'm going to reduce the top and bottom by 2, because I could see since they're both even, they're both going to be divisible by 2. When I do that, I get 3 over 500. Now, 3 is a prime number, meaning it only has 2 factors, 1 and itself. But 500 is not divisible by 3, because if I add those digits, 5 plus 0 gives me 5, and 5 is not a multiple of 3. So I know this here is my final answer. Okay, next one, 0.375. I might also recognize that this isn't a sight fraction, but I can get it using my sight fractions. So some of you might immediately be like, yeah, no problem. This is 3. Oops. It's kind of an ugly 3. It's 3/8. And if you did that, great, props to you. And if you didn't, that is okay, because we could still use place value to help us out. So I get 375. The last digit, the 5, is in the thousandths position. So I have 375 over 1,000. This is not fully reduced. I know for a minimum fact, I can reduce top and bottom by 25. The reason why I'm going with this and not its biggest factor, because this one is what I think most people would be able to recognize the fastest. Maybe 5 first, but 25, hopefully you feel pretty confident with your multiples of 25. Now, we already talked about the denominator. There are 40 25s in 1,000. But I can also think about the numerator. In the numerator, 25 fits into 375, 4 for the first 100, 4 for the second 100, 4 for the third 100, 3 more for the last 75. And I can tell that that grand total is going to be 15. Now, I'm not super satisfied with my final answer because it's still able to be simplified. But if I reduce the top and bottom by using division by 5, I will end up with 3/8. Again, not the fastest route, but still gets us the same final answer. Last 2 questions I notice have repeating decimals. If I have a negative decimal, I'm going to have a negative fraction. There's 2 digits that repeat, which means my denominator is going to have 2 9s in it. Those 2 repeating digits are 8 and 9. If I look at this fraction and go through my divisibility rules, I will notice that it cannot be reduced. So I get negative 89 over 99. Last but not least, I have, before the decimal place, a whole number that is not a 0, or an integer that is non-zero, so I'm going to mixed fraction first. So that 2 that was before the decimal simply becomes this 2 before the proper fraction part. Now, I know that this is a repeating decimal, so it's going to go over 9s. There are 2 digits that repeat, which means it's 2 digits, that means the denominator has 2 9s in it. Those 2 digits that repeat are 0, 1. Now, when I take a look at this, writing 0, 1 is kind of silly, because that 0 doesn't do anything. Since 0, 1 is the same as 1, when we write that numerator, we just want to write the 1. Again, I want my final answer as an improper fraction. And when we go ahead and do this, again, I talked about my mental math strategy. So if I'm multiplying 2 by 99, I will multiply by 2 by 100 minus 1, because the math is faster for me to do in my head. Since 100 minus 1 is 99 anyways, I'm not making a difference in what I'm computing. I'm just making it easier for me to do mentally. So I end up getting 198 plus the 1, so 199 over 99. Now, fun little fact. If I was not able to reduce my fraction when it was in mixed fraction form, I will not be able to reduce my fraction when it's in improper fraction form. Okay, we made it to the end. There is some practice to roll with. Can you please tackle that practice for homework? Okay? I will let you know that not tomorrow, but later this week, we will end up having our first check-in. Now, our check-in is 4 marks, but it will just be a couple of different examples of converting fractions to decimals and a couple of different examples of converting decimals to fractions. I will not ask you to show your work. It is meant to be fairly straightforward, so the types of fractions and decimals you see in that check-in will be similar to what we do and see in class. I will post on Teams of when that's going to be, so please take a peek so that you have an idea. But otherwise, working on that practice is your best first step in feeling prepared for that check-in. I hope you have a really good rest of your day. Bye.